A cylinder which has a diameter of 27 and a height of 30 contains two lead spheres with radii 6 and 9, with the larger sphere sitting on the bottom of the cylinder, as shown. Water is then poured into the cylinder so that it just covers both spheres. The volume of water required is. So the first thing I'm going to do is draw a cross section of this diagram. So here you have the cylinder and you've got the two lead spheres, just a cross section, and they're going to pour water in so that it covers both of those spheres all the way to the top of that smaller sphere. So both spheres are basically submerged in this water, and basically this is all water now. Okay, like that. Now I'm going to need to figure out a bunch of areas here, so I will remove all those lines, but I'll keep the top one to let you know that that is the level of the water. Now we have to label a bunch of radii so that we can figure out some very important distances. So the first thing I'm going to do is draw lines from the center of each circle like that, and let's start labeling what we know. We know that the radius of the small circle is 6. So that's 6, that's 6, and that's 6. We know that the radius of the large circle is 9. So that's 9, this is 9, and this is 9. Okay? And therefore this is 9, this is 6, and this is 6. And we also know that the diameter of the cylinder, which they also labeled there in the initial figure, is 27. So that means from here to here, this whole distance is 27. So this segment will be 27 minus 6 minus 9, which is 12. Okay? And therefore that distance is also 12. And this distance from top to bottom, that distance I don't know yet, so I will call x. And then this is a right triangle. So I can then now use the Pythagorean theorem to figure out x. So we have x squared plus 12 squared is equal to the hypotenuse squared, and the length of the hypotenuse is 6 plus 9, all squared. It's basically the two radii added together. So this becomes x squared is equal to 15 squared minus 12 squared, and that is 81, and therefore x is equal to 9. So this distance is 9. So if I write all the numbers on the side, like here, this is 6. From here to here, we just figured out that's 9. And from here to here, we know that's 9 because it's the same as the radius right there. It means that this whole side is equal to 6 plus 9, which is 24. And that is the height of the water in this diagram. So now what do we have to figure out in this question? How much water is in this cylinder to that level? Okay, I don't want to mess this up too much, but you get the point. The water obviously cannot be inside those green circles because those green circles represent lead spheres that obviously water cannot go inside. So to calculate the volume of water, we would have to first calculate the volume of the cylinder and then subtract from it the volume of the two spheres. So we'll do that here. Volume of water, VW, is equal to the volume of the cylinder minus the volume of sphere 1 minus volume of sphere 2. And that should do it. So the volume of the cylinder is pi r squared times height. The volume of a sphere, just in case you don't know the formula, is 4 over 3 pi r cubed. So Vs1 would basically be equal to 4 over 3 pi r1 cubed, and the volume of sphere 2 is 4 over 3 pi r2 cubed, like that. So pi r squared h, what is the radius of the cylinder? Well, the diameter is 27, so the radius is half of that, 27 over 2 squared. The height, well, the height we figured out was 24. That's the height of the water in that tank. So we have 24 for the height. And then these spheres, the small sphere had a radius of 6, and the large sphere had a radius of 9. So we can factor out a pi, since that is common to everything. And then now we just do the math. 27 over 2 squared times 24. That looks like 729 over 4 times 24. And this is minus 4/3 6 cubed, which is 216. Minus 4 over 3 9 cubed, which is 729. And then this is just some number crunching here. This is going to be 4374 minus 288 minus 972. And if you do that math, you'll get 3114 pi. 3114 pi is the answer, and that represents the amount of water in this diagram, and therefore that would be answer D.